My name is Billy Korando. I am a Java developer advocate at Oracle. I think my profile on here said IBM, but no, I'm no longer there at Oracle. But you can find me on Twitter, where I spend far too much of my time, but please don't tell my boss who's here, at Billy Korando. And this is Java to the Future. And of course, I just decided, to go with that title because of the cool opportunity to use some of the Back to the Future font. So, some important information. Feel free to ask questions. I think we also the break is after this session, so, we have like a little bit more of a buffer as well. So yeah, we should have plenty of time for questions if you want to ask some as well. And definitely feel free to. After all, I am here for you to learn about kind of where Java is going into the future. So if there's something I'm not covering, or maybe could get more depth on, definitely let me know. And again, once again, reach out. You can find me on Twitter, you can shoot me a DM, or you can just feel free to treat me publicly as well if you need a question answered or anything like that. I'll be more than happy to discuss. And you can also email me at billy.korando@oracle.com. And the link to this presentation is at this link, so definitely if there's more information you want, or you want to kind of go back for reference, you can go to this link. And if you would like to know more, here's some great sources. So we have dev.java. That is a website that the Java DevRel team I'm on at Oracle helps put together. We have a lot of great tutorials. There's also information for connecting with the community like CJUG here in Chicago, or of course conferences like here at Jconf as well. So definitely check that out. Inside.java, actually that will probably be even more relevant for this presentation, as that we often post information from the actual developers and engineers on OpenJDK, where you may get information on like the status for Project Loom, or interviews with some of the OpenJDK developers, so you'll really get some good insight on what is coming forward for Java. And of course, we also have our YouTube channel where we have the Inside Java podcast, where we repost it up there, the newscast, Ship of Java, which is something I help usually do with like about a 1 or so minute video on various Java topics, and also Jep Cafe, which my colleague Jose Palmard also posts up there every so once in a while with some really great in-depth information on Jeps or just various Java topics. Actually, if you really want to know about Loom, he has 3 great videos on Loom out there right now. So, I am talking about the future of Java. And so clearly, as Doc Emmett Brown from Back to the Future said, the future isn't written, it can be changed. So kind of take what I'm saying a bit with a grain of salt, actually, as from when I first did this presentation to now, things have gotten a bit more concrete, since there's actually some JEPs being published now, or some actual features being included into the main line of Java for some of these things I'm talking about. But still, there's definitely a possibility where timelines change, priorities change, and of course implementation details can change. If we're finding out that something just isn't making sense in the current way it's designed, that could change. So maybe some of the code examples also, or some of the things I'm talking about, maybe hopefully when they may be delivered, that could change. So don't be like, hey, Billy promised me this thing was going to look like this, or it was going to come in this version of the JDK. That might not happen for these reasons. We're all developers or work in software development, so we know how often timelines can be, best guesses. So let's first talk about Project Amber. So the goal of Project Amber is to introduce smaller productivity-oriented Java language features. I don't know why I decided to do just feats there. I'll have to update the slide. But yeah, of all these projects, Project Amber has definitely delivered by far the most, and actually really the only one that so far has actually delivered full features to the Java mainline. But yeah, so far some of the key language changes that have been delivered have been the updates to switch, pattern matching for instance of records, and sealed classes. So the switch updates, these were added in JDK 14, and their JEP is 361. If you're not familiar, JEP stands for JDK Enhancement Proposal, and it's a really great source of information to get some background on a new feature change, perhaps also even examples of how to use it, and some information like that. Gives me a lot more depth than I can really go into during this presentation. So definitely check that out if you want to get a bit more information on some of these features that I'll be covering. But yes, the updates to Switch. So we're all probably familiar, or we should probably all be familiar with the old colon syntax for Switch. And there's a couple of issues with this syntax. First is it's very verbose to write and look at, so you get distracted by a lot of the structure of the switch versus the actual business code it's actually attempting to execute here in this simple case of trying to print out, every day of the week. But it's not just the fact, verbose just because it's annoying or requiring typing, but it's also an opportunity for introducing bugs by having to have a break statement for each case statement, since generally most of the time when we write a switch case, we're not going to want the fall through by default that is part of switch. We have to put a break in every case, and it's very easy to forget to put a break in there, or during refactoring to remove a break or testing or something, and then all of a sudden you have a bug in production. So it's not just a case of verbosity being annoying to type, it's also an opportunity to make more bugs or introduce more bugs. So in JDK 14, we introduced the ability for the condensed switch statements, in which case you can just, when a case is matched, then only the code to the right of that case is executed. So it's much more condensed, a lot easier to read, there's less structure and more focus on the actual business code, so you're not distracted by, again, the structure of a switch. And of course, less opportunity for bugs as you're no longer needing to include a break statement. Also, switches can be written as an expression. So in this case, we're actually, yielding a value when we match on a case of whatever day of the week that is appropriate. When you're writing a switch as an expression, it does have to be exhaustive. And really, as of right now, that is almost always going to mean you're going to need to include a default case. And in this case, I am throwing an exception on that. So the case or the default or each of the cases would need to either yield a value that matches the value of the expected return or be a throw. So pattern matching is one of the major stories within Amber. In fact, that is where its name comes from. The name Project Amber comes from a series of books published back in the 80s called The Chronicles of Amber. And within that book series is a rite of passage called Walking the Pattern. So that is actually where the name of Project Amber comes from. Initially, I kind of thought it was a tongue-in-cheek reference to Java being stuck in Amber, and then Project Amber being about evolving the language faster, thinking like Jurassic Park with the mosquito in there. And in fact, that's actually one of the images, the Duke image used for Project Amber. But no, that's actually where the name of Project Amber comes from. Anyways, pattern matching is the first example of pattern matching being added for Java, and it was added in Java 16 with the JEF being 394. Instance of isn't as often used, but we probably all have a little bit of experience with it. And here's just a simple example of like, okay, we have some number type, but it could be one of many different number types. And so again, it's a bit verbose to write it out using the older way of using instance of, where you would say like, okay, some number type, is it an instance of integer? Okay, if it is, then we'll go into the if block and then we'll set it. But we have to cast it to being an integer, even though we know for sure it's already an integer. And again, this is an opportunity for bugs where maybe I do kind of a copy and paste between these, and instead I forget to perhaps like update the casting on it or something like that, and I have a bug introduced into my system. So now, pattern matching for instance of will allow us to do a comparison where it's like, okay, is some number type an instance of integer? This is called a predicate in a pattern matching. And if it is, then it will set it to the pattern variable of I. Now, I is flow scoped, and what that means is that it is in scope wherever the compiler definitely knows this to be true, or wherever this predicate is definitely known to be true. And in most cases, what this is going to mean is I is going to be in scope in the following block within an if block, like in here, so I can do work with I in this example, but once I leave this if block, I will once again be out of scope. So you'll still often need to perhaps set this variable to some other, or set this value to some other variable at the appropriate scope. But one of the benefits of this flow scoping is it can allow you to appropriately reuse the same variable name as it makes sense, and not having to think up other arbitrary names. Because if, like, say I was at the scope of like an encapsulating method, you know, then it would have to be like X, Y, Z for each of these different if statements. But because each of these are actually different variables as far as the compiler is concerned, I can continue to perhaps use I here as well. Records, these were added in Java 16 and their JEP is 395. So the first and immediate benefit that developers will kind of get with records is the reduction in verbosity. So let's just say that I was doing some sort of data transformation within the body of a method, and I just needed some sort of handler for this data, for like this person information, just that really only matters within the body of this method. If I was to try to define a class within that method, well, we quickly see here, even the simplest of classes requires dozens of lines to define, where, you know, of course I have the 4 lines just defining the different members of the class, then a canonical constructor, and then I do a hash code and equals and all that. So trying to define that within the body of a method, quickly you lose all reference and understanding of the method because this is completely dominated by this definition of this class. Well, now that can all be defined within a single line here within this example of record. And of course, records, the purpose of them isn't simply to reduce verbosity or boilerplate code. In fact, that really wasn't the primary goal. That's a side effect. The purpose of records is to have a transparent modeling of data as data. And the way we understand that is that, okay, just by looking at person, the definition of person, we already know what we need to know about this class. We know, of course, this name, and we know all of the fields or members that will be included in this class. And we know this because there are some constraints that are put upon records. First, a record, its superclass will always be Java lang record, so it can't be extended, can't be abstract, and is implicitly final. So it can't inherit behavior for some other superclass that you would then have to look at to fully understand the method, or fully understand a record. All the fields within a class or within a record are final, though this is only silently immutable. So if one of these components or fields then within a record was an array or array list, I of course could still modify that array list even after I added it to a constructor. But I couldn't change out that array for some other array because that would obviously be changing out the reference. So that is at least one thing to keep in mind. That you will often want to make sure you're doing defensive copying of values that are being passed into a record just to make sure you're maintaining that immutability. You cannot declare instance fields. So I could not declare some additional instance field like middle name within person within the body of person here. So again, that way we can't have additional behavior within this record that we can't just see from the definition of itself. Now, for all these constraints, we do get some benefits. The compiler will automatically generate accessors, and the accessor will just be the name of, so when we define a record here, these are called components, what then gets transposed into fields. The accessor will just be the name of the component. So if I wanted to get first name out of person, it would be the instance of person.firstname. We'll also generate hash code, toString equals, all automatically generated, though you can overwrite these implementations if needed. Just make sure, of course, particularly for hash code and equals, that you're maintaining that appropriate extension of, equality or computing of hash code. You don't want to, mess that up in some way that would potentially break it. And of course, a good example where you might want to overwrite hash code or equals with the record is if you're using an array. By default, arrays will be matched on their reference and not by value. And so probably typically you will often want to actually match by the value within an array, not just a reference code. So if I had like a record called point, where I just took a int array of values for defining some sort of point, if those values of that array were the same and I didn't overwrite the default hash code in equals, then the compile, or when I compare the two instances of it, they would likely not be equal, even if the values within that array were the same, because it's comparing by the reference of the array, not the values within it. So, like I said, you can override it, and that could be a good example where you would want to override at least the hash code in equals. Sealed classes were added in Java 17, and their JEP is 409. And the way, at least generally right now, I understand the particular benefit of, in most cases for developers, of sealed classes is a way of putting into code domain knowledge about your potential business. So we're all kind of familiar where, you know, there could be some sort of concept of which we may have some sort of hierarchy to it, and there's a limited number of subtypes to it. It's like you have like a transaction type, customer type, account type, or something like that. Every organization I've been a part of had something like that, and there was never really a good way of actually defining that relationship within code. Well, now with sealed classes, you can actually do that, where a class can define who can extend off of it. And so in this example, I put together a really simple hierarchy where user is a sealed hierarchy, defines a sealed hierarchy where only guest, customer, and admin can extend off of it. Now, when you define a sealed hierarchy, these subclasses will then need to define themselves as either final. In the case of guest is a final class, and we just say nothing else can extend off of guest. Customer is a non-sealed class, which basically makes it a normal class where any other class could extend off of customer, or at least any class that has visibility to it. And then admin is itself also a sealed hierarchy, where then we have like a super admin and then a normal admin, which is also a non-sealed class. What does this look like in code? So here we have the new keyword sealed, and then within the definition of our class, and then we would then have the optional keyword of permits that then says, okay, admin, customer, and guest can extend off of user. And as I mentioned then, each of these classes, admin, customer, and guest, would either have to define themselves, in this case, as non-sealed, and non-sealed is actually the first example of a keyword including a hyphen, and then of course it extends off of user. Guest, as I mentioned, was a final, extending off a user, and then admin also extends off a user, and in this case, it's also a sealed class itself, and then it says, okay, normal admin and super admin can also extend off of admin. As I mentioned, permits is an optional keyword. If I was to reference classes outside of the same class or source code file as user, I would then need to use permits to define that these are the only classes that can extend user. If I was to define other classes within the same source file as a sealed class, then the compiler will automatically assume that these are the only classes that can extend off of that class. So they can be inner classes like this, they can also be other top-level classes. That doesn't matter. But yeah, so there's two ways of defining that sealed hierarchy. You either use a permits keyword or defining it within the same source file. And you can't do both. But what are the themes? Like what are the goals behind all these changes? We're not just kind of throwing out these changes, you know, just because it sounds nice. So like there's three major themes I kind of, you know, see with all these. One, to be more expressive. You can more easily define meaning just from looking at the code. Like a good example with that sealed hierarchy, where you can say like, okay, only these kind of classes can extend off of it. That's a good way of like confining or sharing domain information within your code. Safer. You now, particularly we'll see as we get more pattern matching involved, there will be like compiler warnings. Like if I was to, we'll see in a moment, if I was to do pattern matching on a switch that was switching over or doing over a sealed hierarchy, if I was to change that sealed hierarchy to include a new class, I would get a compiler warning saying like, hey, you've added a new class to here, instead of a bug in production, so like our code can even compile because that switch will no longer be exhaustive. There's fewer concerns with nulls, so pattern matching for switch will automatically handle null cases because obviously something can't match on being a type of if it's null, because that would obviously be a null reference type. And then of course also reducing verbosity and ceremony. And like I said, it's not just about typing, but also reducing opportunities for bugs. But another thing that is also kind of what this is all about is about data-oriented programming. And so, we're all familiar with object-oriented programming, and that's where you're writing classes that model business behavior and entities. Data-oriented programming is about modeling classes or classes that model data. Now, it's important to know that OOP and DOP are not competing paradigms. It's not like you either have to accept one paradigm or the other. They can both be worked on together as needed. But kind of the purpose of this, as we're moving a bit away from monoliths to maybe smaller units of applications, microservices or lambdas or functions and stuff like that, we're more often at those data boundaries where we're translating data coming in as a JSON message or working with data that's going out to a database or coming back. So we're more often working with data itself, and these changes allow that behavior, allow that transition to be a lot easier than it was with the existing OOP-only programming model. But of course, someone who's far smarter at describing all of this is Brian Getz, and he wrote a really great article on InfoQ a couple of months ago, so definitely check that out at the link there. But the pattern matching story is far from being done. So pattern matching for switch, if with Java 19, or actually sorry, I think that maybe that's Java 18 that when it entered its third preview, that's Java 19 where it entered its third preview. So what it's allowing, again, is pattern matching on switch, where here, again, we have the predicate. If it's matching on a type of triangle, then it is setting it to the pattern variable of t, and then this will be in scope for the body of this case. And we're also allowing a when clause to then further test that pattern variable for any additional checking that needs to be done on it, instead of having to put that information within the body of the case, instead of like putting like an if statement saying like, okay, if this triangle is greater than 100, then it's a large triangle, and then else within that, printing out that's a small triangle. We can actually put all that within the case label of a switch instead of, again, separating that out into an if statement within the case. When you're writing a pattern or a switch as using pattern matching, it must, again, also be exhaustive. But also with this pattern matching for switches, where we can also see some of the real benefit of sealed classes, where if I was to do pattern matching on a sealed hierarchy, if I was to do it in the sealed hierarchy I showed earlier, I could say, okay, if it's a case of guest, or case of customer, or case of admin, I wouldn't need to include a default case, because the compiler would know that there could not be any other type that it could be. And then if I was to add another type to that sealed hierarchy, then I would get a compiler error saying like, hey, this case or this switch is no longer exhaustive. So that's an example of how code would become safer with some of these changes being introduced in Amber. Record patterns are also in their first preview for Java 19. And so simply put, so like let's say we have this simple record of point where it's, an int of x and an int of y to represent, a two-dimensional point. I can easily deconstruct this point and get the values out of it. And the way it works is it just goes by position compared to the definition of the record. So that's why I used var here and using A and B, as long as like this type here is compatible, and because I'm using var, so it will always infer the type of it, it will match on it. Now if I try to put like Boolean here, that would give a compiler error because that doesn't match how a record is defined. But again, I can easily take those values out of the record and then work with them as needed, instead of like, oh, okay, is this a point, and then having to reference the accessors from point to get the values out of it. And this could be farther expanded upon with like don't care patterns, like maybe I only care about B, then we might be able to have like a matching or only care about the Y of a point. You know, maybe we would have like an underscore here to say like, okay, I don't care about this value, I'm only caring about the Y coming out of points. But again, a lot more coming forward. Going forward, like hopefully we'll be able to get withers with records. So we have an existing record, I just maybe want to update the Y within it. We can do with Y for a value on a record. String templates, or also string interpolation. That is coming. Actually, the JEP for that just finally got like its own proper number. So it's JEP 430 or 430, and hopefully that maybe will be in JDK20. Concise pattern match or concise method bodies, and even more pattern matching as well. For next steps, you can definitely check out the Project Amber on OpenJDK. There's a dev mailing list, and then Brian Getz at the end of last year also published an article on the state of Project Amber. So the next I'm going to cover is Project Panama. And so the goal of Project Panama, like the Panama Isthmus or the Panama Canal, is about interconnecting the JVM with native code. And Panama is composed of three major parts: the vector API, the foreign function and memory API, and the JExtract tool. So the vector API is a way to introduce an API to more expressly compute vectors and be able to optimize them based on the CPU architecture. And so it's currently in its incubator status with JDK 19, and it's going to remain in that incubator status until another project I'll be talking about a little bit later with Project Valhalla kind of starts delivering on some of its features, just because it's going to be so much impacted by those introduction of Project Valhalla features that there's no point of taking it out of incubator status until then. So if you're really reading a vector API and you're like, why is it on the 4th incubator and going to be on the 5th incubator in JDK 20? That is why, and it will remain that way at least until some features from Project Valhalla are delivered. I'll be honest, my experiences as a web developer before becoming a developer advocate, I've never needed to compute vectors, but you know, if this is kind of something you really need to do, Vector API will be able to compute vectors far more quickly than is possible before, and it'll be able to take advantage more of like the hardware architecture that you're running on as well. The foreign function and memory API, and the purpose of that is to provide an API that allows the Java programs to better operate encoded data that is outside the JVM. And it's also to improve upon the JNI, the Java native interface, which is a bit brittle and also dangerous. The foreign function and memory API entered its first preview, so hopefully it will become a general feature here by JDK 21 if it follows the typical 2 previews and then a general feature. Again, foreign function API, not something I've often had to do to work with native code, but here we see a simple example of like we wanted to do some sort of radix search, and so like we have like 4 different string values when we create that in Java. Then we allocate native memory here based upon the length of that string array. Then we copy the values from that string array into the native memory at this point. And then we reference that native library, the native radix sort that is written in C. You can probably do it much faster than you can do in native Java code to then resort that array. And then we copy the values back out of that from that library into the Java code that is then in the proper order. Again, not something I personally have had much experience with when using writing or referencing native code, but what also allows you to do is actually to continue to write in Java code instead of having to more often write in actual native C or C++ code, which kind of by definition most Java developers aren't going to be as familiar with. There's also the JExtract tool, and what that is for, kind of as the little blurb said, is you have some sort of native library and it can mechanically generate Java bindings based upon the published headers of that library. You can find more information on that tool's main page on the OpenJDK GitHub. And again, just the kind of overall encompassing, why are we doing Project Panama? Why are we devoting resources versus devoting resources other places? And like I said, it's replacing the Java native interface with a better API that makes debugging and memory management much easier. And there's also a number of security and safety concerns with the JNI. It's very easy to perhaps make a mistake there of, referencing memory or some other issue that could cause some sort of problem with your application. Or there's also a lot of security concerns there as well. And also, as I mentioned, allow Java developers to actually interact with native libraries while still writing in Java instead of always having to go down to the native code of C. Right now, Project Panama is primarily focused on being able to work with C code. If you're working with C++ code, unless it can be written down into C code, then you may actually still have to kind of work with native C++ code. Again, similar to what I showed with Project Amber, if you want to keep up with it, there is the Project Panama OpenJDK page, there's a dev mailing list. Also, Brian Getz published at the end of last year a state of Project Valhalla. And then one of my colleagues, Dennis McCone, he is writing a really great series on Project Panama. I believe he's on his third article on that series. So definitely check that out. It's primarily focused on the foreign function and memory API. So if that's what's really interested in, or you're kind of working with the Java native interface and kind of want to see what's coming next, definitely check out that series, because certainly before that series, I didn't really know much about Project Panama. Still don't have a lot of great knowledge on it, but it's definitely been very good for like, oh, okay, that's what actually this is all about. Next up, Project Loom. So Project Loom, the goal of Project Loom, and this is probably something many more Java developers here are probably really excited about, because I'm guessing who here is primarily a web Java developer? Raise a hand. What? Really? Oh, okay. All right, kind of surprised. I thought Java developers kind of just support backends for web applications. All the same, probably a few more here be interested in is this Java features for supporting easy to use, high throughput, and lightweight concurrency, while also kind of having a familiar programming model. So virtual threads, there are lightweight threads that can be managed by the JVM to provide far greater horizontal scalability. Virtual threads, they entered the first preview, finally getting added into the mainline JDK release build with JDK 19. Its JEP is 4.2.5. But what virtual threads are is like currently, at least as far as the standard, not using preview features in Java, a thread in a Java, it relates one-for-one with an actual platform thread on your operating system. And this becomes problematic when, again, if you're like a web developer, or for many organizations, or for many kind of applications, because that is a very heavyweight utilization, where oftentimes, and as my colleague Jose in one of his videos kind of puts out, is that you're going to much more quickly run into running out of threads often than before you're running out of memory or CPU usage, because oftentimes those threads, there's a limited number of OS threads available, and a lot of times they're simply maybe making a call out to some other service like a database or a data store or a cache or something like that, where you're just oftentimes waiting for that call to come back. So previously, to maybe kind of address that, reactive programming kind of gained a lot of popularity in the past 5 to 10 years within Java circles, but that kind of comes with like the difficulty, because you're separating the control thread from the thread that's actually executing operations. Again, to use my colleague Jose over here, who has an accent above his name, above the E in his name, perhaps you're making a call with that value to some other service that doesn't really accept Unicode values, and you get some sort of error because of that. It may be very hard to connect that error or an exception you're seeing with the fact that it came from maybe trying to search for Jose's name. So it's very difficult to debug, can be very difficult to test. So virtual threads allow for that horizontal scalability, because the JVM can put these, when you're making a call that's going to be blocked for some amount of time, park that thread just in memory, and wait for it to call to come back, and the JVM won't totally handle that, so it will look all familiar, that familiar blocking style that we've all worked with as Java developers, and it'll also be still easy to test and debug as well. Structured concurrency goes together very well with virtual threads, because let's say you have some sort of task that overall is a single unit of work. Maybe you have a customer coming in, and maybe that customer, you're going to look up like that customer's address, their previous orders, their reviews, and all that stuff. So like you may have like 3 or 4 or 5 calls you need to make at the same time. Instead of having to do that linearly or having to set up some sort of complex thread pool to maybe call that out, structured concurrency allows us to set that up as a block and have all those tasks be broken up into separate tasks that we can execute in separate threads, and then have it all then come together. You can say like, okay, we're only going to wait until like the first call is successful, and then we'll skip on through there. If any of these calls fails, we'll say, okay, then we're going to retry everything, or just throw some sort of exception if any part of that fails. It allows that to be much more easy to understand and treat that all as a single unit of work, but that can also be executed concurrently. And again, this was added in JDK 19. It's currently in incubator status, where I imagine it's probably going to stay here for at least a few iterations before moving into preview and eventually as a general feature. The next thing that's going to be coming for Project Loom is extant local variables, which is kind of confusing from just the name of it. And this will likely be renamed to scoped values. And so what this is a way of providing a lightweight way of accessing immutable variables in the scope that all these threads can access. And this would be preferred generally for when working with immutable values than using thread local, because if you're writing values of thread local and you potentially have hundreds of thousands to millions of virtual threads, and especially if that value is going to be the same across many or all of those virtual threads, all of a sudden you're copying that value a lot of times, and that's going to obviously take up a lot of memory. So when you have some sort of immutable value, it would be good to put that into a scoped variable. Hopefully this will be coming in JDK 20, but then that will still be as an incubator feature. Well, again, it's probably going to stay for a few JDK releases before making its progress into a preview feature and then eventually a general feature. Again, why Project Loom? As I mentioned, platform threads are heavyweight, but many applications, particularly again, web applications, which a very large number of Java developers work on, they use that thread per request model. So every time you have some new person come into your application, making a call into it, that is going to be dedicating an OS level thread to it. And again, you will often quickly run out of threads before you run out of memory, CPU, or anything like that. So by actually decoupling that request from an operating system level thread, we can allow for much greater horizontal scalability that was kind of promised by reactive programming, but we'll then have that same, again, intuitive, linear blocking style that Java developers have been familiar with, again, while getting all that benefit that you would have gotten from reactive programming of great horizontal scalability. Again, for more info on Loom, the videos I mentioned before from Jose are here, so definitely check those out. And for even more information, you can check out the Project Loom page on OpenJDK, the mailing list, and then again, Brian Getz published a state of Project Loom back at the end of last year, so check that out as well. So last project, Project Valhalla, and I kind of put this last because it is the only one that hasn't actually delivered anything yet to the main line of Java, but also is probably one of the most impactful. So the goal of Project Valhalla is to deliver advanced Java VM and language features, and that's actually kind of part of why it's taking so much longer to add new features, because, well, they're going to have a much more profound impact on Java than, some of the smaller features that are being added from like Project Amber. Adding var is a little bit more difficult than fundamentally changing the memory model of Java or changing how types are defined. So what does this mean? So one of the major goals is to unify the type system. Like right now we have primitives and class types or reference types that you're just completely separate out. You know, you can't define any other primitives in the A provided of int, char, long, sort, boolean, and so on. And you know, we can define reference types. But now we're going to be able to kind of unify that because so types, they come with identity and you know, the identity, the memory reference in your code, but that has overhead. You have to be able to store just the identity itself. These types can then be mutable. They can also have locking and synchronization, but that's not always needed. Again, for example, if I was to go back to that record where there's just like the int of referencing a point, you know, that may not necessarily need identity with it. Also references, they have memory indirection, they have nullability, they have protection from tearing. Again, that is not always needed, and that comes with performance costs at both the memory level and the CPU level. So the goal of Project Valhalla is to provide value types which disavow identity, primitive types which disavow identity and reference, allowing for universal generics, so we can actually, you know, have like an array list of ints, not an array list of integers, which again will provide you the benefits of having a primitive types of no memory indirection, no mutability for those values, so much faster performance for both memory or for CPU, and then much memory footprint, and then also eventually specialized generics. But what can you do now, though, to start preparing for Project Valhalla? So one of the major issues with in Java that could affect Project Valhalla is synchronization. So yeah, here if I have a value on a value type for like long and I try to synchronize on it, you know, that doesn't make sense. Could provide a major performance issue. So I would recommend enabling the JFR event sync on our value-based classes, which will let you know wherever that's happening. Chances are you're probably not doing that in your own code, but it could be in some sort of library that's occurring in, and that'll let you know to where perhaps you should update it. If you're not familiar with what JFR is, JFR stands for JDK Flight Recorder. It is a really great tool for getting observability into both your JVM and Java application. We definitely recommend it. It's actually built in within the JVM. I've done a few SIP videos on it as well on how to get it started, and I even have like a video on also how to get started with JDK Flight Recorder. Much longer presentation than we can cover here. But definitely check that out, and again, it's a good way to get prepared for Project Valhalla, which, you know, still a couple years off, but before it releases general features, but maybe hopefully preview features will be arriving here pretty soon as well. Also making sure not to initialize value-based classes as well. Again, to use the long example, this will give you a compiler warning as the constructors for these classes are no longer are being deprecated. So like that started a while back with like long ints, like all the autobox values like map closely to the primitive type, but then it's also extending out things to like locale. Locale, the constructors for locale were deprecated in JDK 19. And again, the reason why is because long, you know, a value of 100, that would be the exact same thing as any other instance of that. So it doesn't make sense to allow for the creation of a new instance of what would essentially be the identical copy. That's why identity doesn't make sense for something like a long. And of course, I would also apply for locale. You know, there would only be one instance of English-speaking United States. You wouldn't have multiple instances of that because that wouldn't conceptually make sense. You wouldn't have multiple different types of that. You know, there could be multiple United States, like an English-speaking one or Spanish-speaking one because of the difference in, you know, Spanish across different countries or English across different countries, but you wouldn't have multiple instances of that because conceptually that just wouldn't make sense. So that's a kind of a concrete example behind why identity isn't always needed with a class when it doesn't really make any sense. So again, why are we devoting so much time to Project Valhalla? I think actually in the state of Project Valhalla that I will link to later, James Gosling, who was the original architect behind Java, described Project Valhalla as 6 PhDs all kind of put together. So again, that's why Project Valhalla, despite starting back in 2014, hasn't really delivered a whole lot yet to mainline, is because, well, it's a very, very difficult change that's being put into Java. But again, it's to take better advantage of modern hardware design for both memory and CPU usage. When, going back to the vector API, when wanting to calculate mathematic values, if you're kind of having to do that with like big decimal or big number or something like that, you're adding in a bunch of overhead with identity and reference, where again, it wouldn't make any sense because a number is by its own nature unique. Being able to allow that to write that as a primitive that disassociates reference and identity would allow for much faster computation than was possible before. And it was also about healing the rifts that often crop up within our code between primitives and objects with universal generics, and eventually then going on into specialized generics as well. So what are the next steps? Again, check out the Project Valhalla OpenJDK page. That's for this project and for the other projects. That'll give you a list of like the current JEPs that either have been delivered or are coming on delivery. The dev mailing list, of course, is a great way of finding out what is kind of going on within these projects. Changes, updates. Oftentimes the difference in opinions and the fights kind of happening are fights or heated discussions that might be happening on how to imply and implement some of these features. Again, whether it's Project Valhalla, Loom, Amber, or Panama, oftentimes there's very complex discussions, particularly around the edge cases on how to implement these things. And of course, when there is millions of Java developers out there writing on, hundreds of millions of potentially billions of different applications, those edge cases, even if it's like 0.001, is going to actually come up thousands of times. So it makes sense that we really want to make sure about these edge cases and go about and addressing them in a concise manner, and not just be like, no, I know it's going to ever want to do that or something like that. Those mailing lists are, of course, where those discussions occur. And finally, as with the other projects, at the end of 2021, Brian Getz did also put together a state of Project Valhalla, so definitely check that out if you're very interested in Project Valhalla. So a few other follow-up links. I mentioned earlier how we have our newscast, and so about every other week we publish a video, and the most recent one we actually get a rundown on how libraries and tools and stuff like that are being updated to incorporate Project Loom. Because, for example, Project Loom, if you suddenly have hundreds of thousands to millions of threads, where we're kind of generally used to maybe dozens to hundreds of threads, things like debuggers are going to have to update to be able to properly display that, or how you would actually properly debug that. So like we're talking about how tools, our IDEs are updating to handle that. Of course, obviously, for application servers, that is also going to have a dramatic impact if Tomcat or Netty or Jetty start taking advantage of putting user requests as virtual threads instead of system threads. That's going to greatly increase their scalability. So anyways, we kind of go through how the community is working to support Project Loom in our most recent video, and then other videos we have recently published also touch upon the other various features like Panama and Amber that have been released in recent JDKs. So I actually linked to the playlist, and kind of you can check through that to see which of those videos might interest you. With that, thank you, and again, please reach out at Billy Korando, or you can send me an email, and a link to this presentation with all the links is here, and I'll make sure to, I did have to make a few updates just before this presentation, but I'll make sure to push that up there, within a few moments as well. So are there any questions then? All right, well, if you do come up with some other question, feel free to come up here, or I'll be here for the next couple of days, and I'll be also happy to answer any questions you might have. All right, well, thank you, everyone.